Hey guys, in this video I want to discuss the chain rule and differentiation. So what is the chain rule and when do you use it? Simply put, the chain rule is used for differentiation when there's a function inside another function and it would be harder to differentiate using distribution or anything else. It's actually much easier than it sounds, so let's just go ahead and do a practice problem and hopefully that helps clarify the concept. You can pause the video and write down any step and follow along. So the problem we're starting with is y equals x cubed plus 3 raised to the 5th power. Without using a chain rule, how else would we differentiate it? Well, we could go ahead and distribute, but notice that the entire expression inside the parentheses is raised to the 5th power. So that would take a really long time and we'll probably make a lot of mistakes. And this is when we need to use the chain rule. First, let's identify the function inside a greater function. Well, I can say that the expression inside the parentheses would be the inner function. So let's just call it f of x. F of x equals x cubed plus 3. But y doesn't equal f of x. Y is equal to f of x raised to the 5th power. Now, f of x raised to the 5th power is equal to x cubed plus 3 raised to the 5th power, and that equals y. So now if we wanted to find y prime, what we could do is just differentiate it as if this was an x. So bring down the 5 as a coefficient. So 5 times f of x, now subtract 1 from the exponent, so 5 times f of x raised to the 4th power. But we're not done. Since we have f of x inside the parentheses, we need to multiply this entire quantity by the derivative of f of x. So now let's go back up here and find the derivative of f of x. F of x is equal to x cubed plus 3. The derivative of x cubed is 3x squared, and the derivative of a constant is just 0, so we don't need to even write that. So now we just multiply this entire thing by 3x squared. Now we can just go ahead and replace f of x with x cubed plus 3. So 5 times x cubed plus 3 raised to the 4th power times 3x squared. Now we can just simplify and multiply 3x squared times 5 and get 15x squared times x cubed plus 3 raised to the 4th power. And that's all the chain rule really is. Notice that this was much simpler than distributing x cubed plus 3 to the 5th. And this is an ideal case where you would use it. If it was something like x to the 5th, you don't need to use it. And that's all the chain rule really is. And now let's do another problem just to clarify the concept a bit more. We have y equals square root of negative 2x squared plus 1. If we wanted to, and we can just say whatever's inside the square root is the inner function. So we'll say f of x is equal to negative 2x squared plus 1. But y is not equal to f of x. Y is equal to the square root of f of x. And square root can also be written as f of x raised to the half power. Now we can just derive this like we did with the last problem. So y prime is equal to, bring the half down as a coefficient, half f of x times half f of x raised to the negative half power, and then multiply this by the derivative of f, and f prime of x is just multiply the 2 with the negative 2, negative 4x, and the derivative of a constant is just 0, so we don't need to worry about that. Multiply this by negative 4x, and now we can go ahead and replace f of x with negative 2x squared plus 1 raised to the negative half power times negative 4x. But we don't like leaving negative exponents, so what we'll do is just rewrite it. Y prime is equal to, and now we can start simplifying. Half times negative 4x is just negative 2x, so negative 2x. And when we have something raised to the negative power, it just goes in the denominator, and something raised to the half is just square root of that, so negative 2 square root of negative 2x squared plus 1, and that is the final answer and the derivative of y. That was all for the basics of the chain rule. I'll do more problems in later videos. Hopefully this helped a little, and if you have any questions, don't hesitate to comment below. If you haven't already, please do subscribe, and I'll see you guys next time.